Okay, so we'll start lecture. Okay, so welcome to lecture number 19, and today we'll basically take some problems on block diagram reduction techniques. So initially I'll take some block problems on single input, single output system, and then later on at the end I'll take some problem on multi-input, multi-output system. That given a complicated diagram or given a complicated block diagram, how to reduce into a single block and how to find out the overall transfer function. In the earlier lecture, we have studied already that part, and we have taken two problems on that one. And in this lecture, we'll continue with it, and we'll basically uh, we'll solve some more problems on that one. So that will help you to understand this how to find out the overall transfer function by using block diagram reduction technique. So that we will do in this lecture. Okay. So the next problem on this one is, okay, like for example, this is the block diagram which is given, and you'd like to find out overall transfer function of this system. So as I said, that when you look at any block diagram, complicated block diagram, first thing is that you have to look whether there are any two blocks which are connected in cascade or not. So if they are connected in cascade, then you have to basically solve that. Okay, you have to simplify that by using first rule. Like when two or more blocks are connected in cascade, then you have to find the overall transfer function, and that is equal to basically the product of two or more blocks gain, and so on. So here, if you look at this problem, I don't think that there is any two blocks directly connected, because if you consider this Z3 and Z4, in between Z3 and Z4 there is a takeoff point. So these, we cannot say that these are directly connected or like in cascade form or like that. So for that, what we have to do is basically we have to shift that takeoff point after a this one. We have to shift that takeoff point after a block, and this takeoff point after Z4, and then those two blocks will be in a cascade. Like for example, if you shift this takeoff point behind this Z4, then and then the Z3 and Z4 will be in a cascade form. So first, to eliminate the loop of Z3, Z4, H1, Z3, Z4, H1, we will move this one H2 block behind this G4. So you know that when you would like to shift this takeoff point after a this one after a block, so what you have to do basically, you have to use that rule, and we have to modify that block diagram so that, okay, this one, sorry. So here, see that if you shift this H2 block or this takeoff point after this one, then you have to modify this gain of this transfer this block by dividing this Z4. So this will be H2 by Z4. See, just I'm shifting this takeoff point here. So see that what happens basically, if we shift this takeoff point here, then we have to add one more block here, whose transfer function will be equal to 1 by z4, and then these two blocks will be in cascade. So I have written directly this h2 by z4, right? Now see that here, now okay, after shifting this takeoff point here, now this z3 and z4 are in cascade, so we can directly multiply this transfer function, and then we'll get one block only here, and this block will be in loop with this one. So you can apply the loop formula. This first thing is that you have to apply first formula, that is z3 and z4 will be in cascade, and so you can reduce into a single block, and then after that you can reduce the loop into this loop into a single block, and so on. So see that okay, after removing this one, this z3, z4 and g4, we can eliminate this one. So g3, z4 will be in cascade, and then h1. So here feedback is positive, so definitely z3, z4. So if you eliminate this one, what will be the one block, that transfer function of that block? That will be z3, z4 divided by 1 minus, because this is plus sign, so 1 minus z3, z4 into h1. So you'll get one block here, and that block will be in cascade with this one. So you can reduce that one into a single by just multiplication of it, and then after that this will be in loop with this one. So just let us go step by step here. Like, okay, so you got this one by eliminating this block, by eliminating these three blocks into a single block. So you know that first applying first rule, you'll get g3, g4, and after applying third rule, you can eliminate this by loop elimination formula. So you got this g3, z4 divided by 1 minus z3, z4 and h1. Now, so by elimination, you'll come across the situation that G2 and this block will be in cascade. So if two blocks are in cascade, then you can just multiply the gain of these two blocks, and you can obtain the individual or single block having transfer function equal to this one. See that how it will be like this after elimination. So after elimination, so eliminating the loop, this one, so h2, g4. So before that one, just you have to multiply this, and then after that you have to eliminate this loop. So how you'll get, so z2 into this z3, z4 divided by 1 minus z3, z4, h1, and this will be a forward path transfer function, and this will be a feedback path transfer function. Here feedback is negative feedback, so you can reduce this entire block and this block into a single block, and after reducing this one, you'll get g1 in cascade with that block. So see that after eliminating this situation, what you get the okay, after elimination of this one, so g2, g3, g4 divided by 1 minus z3, z4, h1. So this will be the transfer function of this block, and then after elimination of this loop, you will get this transfer function g2, z3, z4 divided by 1 minus z3, z4, h1 plus z2, z3, h2. So after elimination of this these three blocks. Now, this block is in cascade with this one. So you know that when two blocks are in cascade, just you have to multiply. So this will be z1, z2, z3, z4 divided by 1 minus z3, z4, h1 plus z2, z3, h2. And the whole block will be in loop with this one. Now, what kind of feedback is there? Negative feedback is there. So just you have to apply the loop elimination formula, and then finally you will get the transfer function of this complicated block diagram by elimination of this loop with h3. You will get the final result as z1, z2, z3, z4 minus z3, z4, h1 plus z2, z3, h2 plus z1, z2, z3. Just okay, you have to apply the loop elimination formula here. So cs by rs or ys by rs will be this one. So this is the overall transfer function of given block diagram, and so on. So I hope that you have understood this problem, and okay, so if you have any doubt about this problem, you can ask frankly. I will okay, I'll explain if you have any doubt or like that. Okay, so is this clear? If yes, just say yes, and then I can proceed further.
Yes, sir.
Okay, go ahead. We'll go ahead. Now we'll see this problem. Okay. So this is the problem from the NIS book of okay page where page number 242 is there, and now see you have to find out the solution. That you have first you have to find whether two blocks are connected in cascade, then whether two blocks are in parallel, if not then if two blocks are in loop, and so on. So like that way you have to find out all those things, and then you can take the decision or reduce that one into a single block and so on, right? So here see that uh, this okay what will be the okay what will be the our first step. Our first step is that these two blocks are in cascade, so we can reduce into a single block having transfer function of just multiplication of these two blocks, so g2 into z3. So you got one block. Now this block is in loop with this H1, and now this is the negative feedback. So Z2, Z3 divided by 1 plus Z2, Z3, H1 will be the loop elimination after that. So you'll got one block. So this block will be again in loop with this H2S, but this is basically a positive feedback, so you can eliminate that one. So whatever you get, that will be in loop with this H3. So this is also negative feedback, and you'll get one block of that one. And then finally, whatever the block you get, that will be in a cascade with G1. Just you have to multiply it. So just applying the given rule, you can solve this problem very quickly. Like, okay, so by first we'll do elimination of this loop. Okay, so first three summing junctions can be collapsed into a single summing junction. Also, that can be also possible here. Okay, so like this way, and then second, recognize that three feedbacks H1, H2, H3 are connected in parallel. They are okay. So here, in other way, also you can basically solve this problem. Okay, instead of going with this usual method, you can also solve this problem by reducing this parallel into a single block. See that this block is connected in parallel with this block. H1, H2, H3 are connected in parallel, right? So we can just add this one into a single. So you can reduce the number of combinations. So what will be this one? Only one block, then minus H1 plus H2 minus H3. So H2 minus H1 minus H3 will be the single block transfer function here, and that will be in loop with this G2 and Z3. So that will okay reduce very computations very efficiently. So you can look at this one. So this is H1 minus H2 minus H3. This is in loop with, okay, by taking negative feedback here. If you take positive feedback here, then H2 minus H1 minus H3. But if you take negative feedback, then this will be H1 minus H2 plus H3. Now this block and this block is in loop with negative feedback, so you can reduce that one by using by applying the loop elimination formula. And then if you get one block, that will be in cascade with this G1 of S, right? So you can solve that problem very quickly by using that simple formula. Okay, so see that what happens basically after reducing this one. Okay, so this is okay after taking the feedback, basically eliminating the feedback loop by using a loop formula and just multiplying this one, you will get final transfer function as z3 into z2 into z1 divided by 1 plus z3 z2 into h1 minus h2s minus h3s. So this will be the overall cs by rs transfer function of given problem. So in that way, you can solve this problem. I hope that you have understood. You can solve by any way, but finally your result should be same, right? Now, another problem, eighth problem, you can solve. So, okay, so how do you solve this one? Can somebody tell me, okay, what should be your first step? Here. This is the problem from Ogata book, page number 47. Yes, please. Can somebody tell me how to solve this one?
We can take G4 in the H3 loop, like it is.
Means you'd like to shift this
Yes,
takeoff point after this one,
yes. So
right?
G3,
So
G4 can come
okay, so
together.
right, in cascade, G3, G4 will come in cascade. H2 will be in loop, right?
Yes,
Okay, but when you're shifting this one, you have to modify H3 also, no?
yes. You have to modify H3.
So H3 will be H3 by Z4. When you are shifting this takeoff point, so it will be H3 by Z4, right?
Yes,
So your first step will be like that, and then after that, this G3 and Z4 will be in cascade, and then the whole thing will be in loop with H2. And then once you reduce that one, Z2, and then whatever the block you will get, that will be in cascade, right? And then after that, H3, okay, let us see what happens basically, because here again, that will create a problem here. Okay, so you have to shift that H1 again after that, right? So let us solve step by step. So first thing is that we'll shift this takeoff point here. So when you're shifting this takeoff point here, you have to modify this H3 by Z4, right? So here, first move the branch point between G3 to Z4. So between Z3 to Z4 to the right hand side, the right side of the loop containing Z3, Z4 and H2. So and right, so we can move that one. So see that when you are shifting this takeoff point here, you got this H3 by Z4, and also you are just shifting this summing point here. Okay, so rearrangement of this summing point, so that this will also solve that problem. So when you are shifting that summing point here, you have to modify this one by Z1. So you got this one. Now this block diagram has become very simple. This one. So what is that? Z3, Z4 will be in cascade, and this is in loop with this one, negative feedback. Z1, Z2 in will cascade, and this is in loop with this one. And whatever the elimination you get, that will be in cascade with this one. And then after that, this whole thing will be in loop with this one. So see that. If you solve this one, what will be the loop, this elimination of this one? Z3 into Z4 divided by, since it is negative feedback, so Z3 into Z4 divided by 1 plus Z3 Z4 H2, right? So this will be the transfer function of this block or loop. What about this one? It will be Z1 into Z2 divided by 1 plus Z1 Z2 H1. Now this is one block, this is another block. Just multiply it, you'll get one block here. And then this whole block will be in loop with this H3 divided by Z1 Z4. And then this is positive feedback, so you can use the appropriate formula and then reduce into a single block. Now let us go ahead with that one. So by simplifying this one, what you got? Eliminating two loops, you got this Z1 Z2 divided by 1 plus Z1 Z2 H1, and then Z3 Z4 divided by 1 plus Z3 Z4 H2. Now these two blocks are in cascade, so just multiply it, you'll get one block, and then this whole block will be in loop with this one, but loop is positive loop, right? So you can reduce that one. Okay, so see that. Okay, so you can reduce that one into a single block. Okay, so this is after this reduction. Okay, what you get? You will get this Z1, Z2, Z4, Z3, Z4 divided by 1 plus Z1, Z2, H1 in one bracket, and in another bracket 1 plus Z3, Z4, H2. So this will be the whole transfer function of this forward path, and then feedback path will be H3 by G4. Now just you have to use the appropriate formula of loop elimination. Finally, you will get Z1, Z2, Z3, Z4 divided by 1 plus Z1, Z2, H1 plus Z3, G4, H2 minus and so on. So by appropriate elimination, you can get the final transfer function of this complicated block diagram, right? So you can obtain that transfer function like CS by RS will be this one, right? CS by RS, this is the result of CS by RS, right? Okay, now we will continue with this one. We'll study on multiple input, multiple output system. Okay, so multiple input, multiple output system, what you have to do for finding the transfer function of multiple input, multiple output system. So here you have to use a superposition principle. Superposition principle means you have to consider one input at a time. At that time, you have to set other input as zero, and then you have to find out the transfer function. Like for example, R1 is one input and C1 is one output. R2 is another input and C2 is second output. Like, so you have two input R1, R2, and you have two outputs C1, C2. So multiple input is there and multiple output is are there. Now, how to find out the overall transfer function? So at that time, what you have to do, when you are considering R1 as an input, at that time you have to consider R2 as 0 and just find out C1 by R1 transfer function. So you got C1 by R1 by eliminating R2 or by setting R2 equal to 0. Now, once you find this C1 by R1, keep as it is. Then when you are considering R2 as input, at that time, consider R1 as 0 and then find out C2 by R2, right? So C2 by R2, you got now in first phase, you got C1 by R1. In second phase, you got C2 by R2. The overall transfer function C by R or CS by RS will be equal to C1 of S by R1 of S plus C2 of S by R2 of S. So what you have to do? Set all the input except one equal to 0. Like multiple inputs are there. So when you are considering that input, you consider that input as it is, and then all other input you have to set that equal to 0. Then you have to reduce or transform the block diagram to a canonical form or a simple loop form using the transformation section, and then calculate the response due to the chosen input acting alone, like by using superposition principle. Repeat these steps 1, 2, 3 for every input, remaining input. At that time, other inputs are considered as 0, and then algebraically add all those transfer functions, you'll get the overall transfer function. I hope that you have understood how to find out the this one overall transfer function of multiple input, multiple output system, right? If if you have any doubt about procedure, we are going to take the problems, okay? But regarding procedure, if you have any doubt, I'll be happy to answer those that doubt. Okay, over to you. For multiple input, multiple output, you have to use superposition principle. Superposition principle means when you are considering one input, at that time, you have to consider other input as 0 and then find out the transfer function C1 by R1. When you are considering second input, okay, at that time, you have to consider first input as 0 and then you have to find out the transfer function C2 by R2. If there are three inputs, then you have to consider, suppose for example, R3 you have considered. At that time, you have to consider R1 and R2 as 0 and find out C3 by R3. Okay, and then suppose for example, there are only three inputs and three outputs. So you have found C1 by R1, C2 by R2, and then C3 by R3. Once you have calculated that one, then according to superposition principle, just you have to add algebraically, that is C1 by overall transfer function CS by RS equal to C1 by R1 plus C2 by R2 plus C3 by R3. So in that way, you can solve the problem, or you can find out the overall transfer function of multiple input, multiple output system, right? So just look at this one. Okay, multiple input. Here, one input is R, another input is U. Okay, and then suppose for example, common output is there C. So when you have to find, so you have to find out C by R and also U C by U. So when you are considering R, at that time you have to consider U as 0. When you are considering U, at that time you have to consider this R as 0. And then you'll get two transfer functions, and just you have to add these two transfer functions. Okay, so determine the output C due to input R and U using superposition method. Now suppose for example, you have considered R, and means first input you have considered and second input you have made 0. Now if this U is 0, then there is no meaning of this summing point now. So this, okay, we can eliminate that summing point because this, okay, input is 0. So this, there is only one input and then output same. So input and output are same. So there is no meaning of this summing point. So this G1 and G2 will be in cascade, and you'll get G1, G2, and then this is in unit feedback. So overall transfer function C by R will be equal to Z1, Z2 divided by, since this is negative feedback with unity feedback, so Z1, Z2 divided by 1 plus Z1, Z2 will be the value of C by R. Are you getting? See, when R is considered and U is absent, when U is made 0, so this signal is 0. Now for summing point, one input is 0 and other input is there. So output will be same now. So there is no use of this summing point. So you can eliminate this summing point, and then because of that, G1 and G2 will be in cascade. So you can use first formula. Okay, so Z1, Z2, and now this Z1, Z2 will be in loop with unity feedback, and this is negative feedback. So Z1, Z2 divided by 1 plus Z1, Z2 into H1 is here 1, and that will be equal to C by R, right? Are you getting? So see that, put U equal to 0 and the system reduces to what? System will reduce. If U equal to 0, this will be of no meaning, and G1, G2 will be in cascade, and this will be with a unit feedback with this one. So CR by R will be equal to what? Z1, Z2 divided by 1 plus Z1, Z2, right? So your transfer function will be equal to output CR due to input R is CR equal to Z1, Z2 divided by 1 plus Z1, Z2. Or if you take this R here, CR by R will be equal to Z1, Z2 divided by 1 plus Z1, Z2. Have you understood up to this point? This is very simple problem. Okay, we are going to increase the complexity of the problem in next. Let me know whether you have understood this hop problem, because we have to calculate this C by U. If you have any doubt, you can ask me frankly. I'll repeat it again. Waiting for your feedback.
Yes, sir. Understood.
Okay, fine.
Clear, sir.
Okay, that's good. That's good. Okay, now, so this hop problem, you have found transfer function when R is present. Now, in the second stage, what you have to do? You have to make this R as 0, and you have to consider only U. Now, if R is 0, so this input to the summing point will be 0. What will happen basically? If it is 0, then there is no meaning of this one. So this Z1 will be in loop with this Z2 now, right? So just look at this one. When put R equal to 0, okay, and you are considering only U at that time. So when R is 0, so this summing point will be eliminated, and then this Z1 is, since you have this initially, so this is the negative feedback now, negative feedback, so -1 will be there, and then -1 block will be there in cascade with Z1, or you can directly make the sign of this one as a minus Z1, right? So that's why here -1 is there, and then G1. So these two blocks are in cascade. So minus Z1 will be there. And now this minus Z1 is in basically positive feedback is there. So this with Z2. So Z2 will be the forward path, and then minus Z1 will be the feedback path. So what will be the transfer function of that one? Can somebody tell me? CU by U. A very simple problem. CU by U. Can somebody tell me? What
G2 upon 1 plus G2.
What about G1? Because G1 is H1 now. G1
Yes,
is
so G2 upon 1 plus G2.
G2 upon 1 plus G1, G2, right?
Yes, sir.
Yeah. So CU by CU by U will be equal to Z2 upon 1 plus Z1, Z2, right? So this will be the basically overall transfer function Z2 upon 1 plus Z1, Z2. So that will be your transfer function, final transfer function. Okay. So that is Z2 upon 1 plus Z1 Z2. Now this is when you have U input and R is considered at 0. Now you have found CR by R and you have found CU by U. So overall transfer function will be just addition of that one. So you can add the total output C will be equal to CR plus CV. So this will be basically Z1 Z2 divided by 1 plus Z1 Z2 into R. So and plus this this is the output due to V and U, and this is the output due to R. So this will be the overall basically output when you are considering the multiple input multiple output. I hope that you have understood this problem, right? If yes, we can go ahead. Yes, please. Okay, then now consider this problem, okay, where three inputs are there. One is R input, another one is U1 input, and third one is U2 input. Okay, so when you are considering R, at that time you have to consider U1 as 0, U2 as 0. So when you are considering R as an input, U1 as 0, U2 as 0, what will happen? This summing point will be eliminated, this summing point will be eliminated, and then this will be in cascade with this one, this will be in cascade with this one, and then whole thing will be in positive feedback with this one. So can somebody tell me directly the transfer function of this when you are considering R as an input? Quickly.
Sir, G1 G2 upon 1 plus G1 G2 H1 H2.
But this
One
one
minus,
right? Yeah. So G1 G2 divided by 1 minus G1 G2 into H1 H2 will be the C by R, right? Very good, very good. So when you are considering R as an input and U1 U2 as 0, you will get this arrangement like this. So this is positive feedback, so you have to consider a denominator signal sign as negative, and you will get Z1 Z2 divided by 1 minus Z1 Z2 H1 H2. So that will be CR by R if you take R this side, right? Now when you are considering U1, at that time you have to consider R as a 0 and U2 as a 0. So when you are considering R as a 0, U2 as 0, what will happen basically? You can eliminate this summing point and this summing point. So can somebody tell me, when you are considering U1 as input and then R is 0, U2 is 0?
Sir, it will be G2 upon 1 minus G1 G2 H1 H2.
Very good, right? And then when you are considering this U2 as an input, okay, let me, for other students also, let me, when you are considering U1, at that time R and U2 will be 0, and then this one you will get finally whatever you said just now, that will be equal to C1 is equal to Z2 upon 1 minus Z1 Z2 H1 H2, right? So if you take C1 by U1 will be this one, right? Now when you are considering U2 as input, and at that time you have to consider R as 0 and U1 as 0. So your output will be equal to, see that when R equal to 0, U1 equal to 0, and you are considering only U2, so your arrangement will be like this, Z1 Z2. Now this block is in cascade now, right? Can somebody tell me what is the transfer function of this block, the entire system, C2 by U2?
H2 by 1 minus H1 G1 G2.
Which is forward path, which is feedback path?
Oh yeah, right.
So tell me, which is forward path first?
Forward path is H1 G1 G2.
Very good. And feedback path is
H2.
Right. Here, what kind of feedback is there?
Positive.
Positive feedback is there. So your denominator side will be negative. So it will be Z1 Z2 H1 divided by 1 minus Z1 Z2 H1 G1 G2 H1 and H2, right?
Yes.
Yeah. So this will be the overall in this one, like C2 by U2, it will be equal to Z1 Z2 H1 divided by 1 minus Z1 Z2 H1 H2. So this is C2 by U2. Now you got C2 C by R, you got C1 by U1, and then you got C2 by U2. Overall transfer function is just addition of all those things. So Okay, so you'll get by superposition principle C is equal to CR plus C1 by C1 plus C2. So just you have to add all those things, right? And if you are this is output, but if you want to find out the transfer function, so you have to take this U2 here, C2 by U2, and just add that one, right? So that will simplify. I hope that you have understood this problem. Now here, this is the last problem, I think. Multiple input, multiple output system. So find out C1 and C2 due to R1 and R2. Okay, so what will be there? If you are considering R1, at that time consider R2 as 0. So if you are considering R1, then output is C1. If you are considering R2, then output is C2, right? So when you are considering R1, at that time you have to consider R2 as 0. So if you are considering this R2 as 0, so this summing point will be removed, and then you have to simplify it. So what will happen basically? See that when you are considering R2 as 0, this block and this block will be in cascade, and then again see this C2 will be 0 at that time. Again this block will be in cascade. So Z2, Z4 and Z3 will be in cascade. And now see that this is negative feedback now. So negative, and then again this is negative. What will happen? Can somebody tell me? When you are considering R1 as input, at that time R2 is 0 and C2 is also not considered. So if this is removed, so there is no point of this summing point. So this Z2 will be in cascade with Z4, and this will be in cascade with G3, and that will be in loop with this one. So your forward path transfer function will be Z1, and your feedback path will be what? This is minus sign, and again this is minus sign. What will happen? Minus minus, it will become plus now. Are you getting?
Yes, sir.
Okay, so your feedback path transfer function will be equal to Z2, Z3 and Z4, but this will be plus sign here, right? And forward path is Z1. So overall transfer function C1 by R1 will be equal to what? Z1 divided by 1 minus Z1, Z2, Z3, Z4, right? So that will be equal C1 by R1. Okay, so just look at this one. When you are considering R1, okay, at that time you have to ignore C2 and R2, okay, and then you will get this one, okay, Z1 is this one, and then Z3, Z4 is this one. So you have to eliminate that one. So see that by considering this R2 as 0, so this will be again in cascade, and then this will be like this. So by eliminating this one, what do you got? This positive feedback, and then in loop Z2, Z3, Z4, and then this is in forward path. So this G1 divided by 1 minus because of this positive sign, 1 minus Z1, Z1 divided by 1 minus Z1, Z2, Z3, Z4. That will be C1 by R1, right? And so that is the transfer function when you are considering first input. Now, when you are considering the second input, okay, so this is overall transfer function of this one. When you are considering second input, at that time, R1 will be 0, right? And only R2 will be present. And then see that if you go back to this one, when you are considering R1 as 0, and C1 is not considered, at that time only R2 and C2 is considered. So if this is 0, what will happen? This will be eliminated, and then you have to simplify this one. See that when it is 0, there's this G1 will be in cascade with this one, and also Z3 is in cascade with this one, and then whole thing will be basically in loop with Z4, right? So your feedback path gain will be the product of these two, these three, and okay, you have to see the appropriate sign. What happens basically here? See that when now you are considering this one. Okay, so when you are considering R1 as 0, so you R1 as 0 and only R2 is considered. So your feedback will be Z1, Z2, Z3, and forward path transfer function will be Z4. And then because of minus sign, it will be +1. So this is positive feedback. So forward path transfer function is Z4. So Z4 divided by 1 minus Z1, Z2, Z3, Z4. So that will be equal to C2 by R2. And then overall transfer function will be C1 by R1 plus C2 by R2. Okay, so that you can find. You can easily find the overall transfer function, right? So in this way, you can solve the problem of multiple input, multiple output. Okay, I hope that you have understood block diagram reduction technique of any complicated block. You can solve the problem, and you can find out the overall transfer function of given system by using block diagram reduction technique. If you have any doubt, you can ask frankly. Otherwise, we'll call it a day.
Sir, can you again show the last slide, please?
Sure. See that? This one?
Yes, sir, that last 17 one.
All right, just 1 minute. See that? By simplifying this one, you got this one. Okay. Any doubt?
No, sir, clear.
Okay, fine. Okay, so we have finished this topic, that block diagram reduction technique. Now only one point is left from this chapter, and that is signal flow graph. See that finding the transfer function of a complicated block diagram by using block diagram reduction technique is a bit tedious. You have to apply several rules. But can we find the overall transfer function in a single shot with another technique? So it is possible by using signal flow graph. So in our next lecture, we will start signal flow graph. So first we'll understand the basic concept of signal flow graph, and then how to find out the overall transfer function. That is the quickest method to find out the overall transfer function of any complicated system, by using SFG. So here we will stop, and next lecture we'll start signal flow graph technique, right? So I'll stop here.